So hello dear students, today we will study the effect of Coriolis force on a particle moving on a surface of Earth. This is another article towards our study of fictitious force which arises due to the accelerated motion of frame of reference. So for this, consider Earth revolving from west to east. With angular velocity omega vector about its axis of rotation. Let omega vector lies in xy plane and lambda be the latitude of the point P where body of mass M is placed. Detailed diagram you can see in our previous lecture. So omega vector as it is lying in xy plane, yz plane. As it is lying in yz plane, so it will be having two components, one along y-axis, another along z-axis. First component is cos component, second component is sine component. We mark this equation as equation number 1. So we assumed Earth to be moving with angular velocity omega, which is lying in yz plane, and due to the latitude lambda we have two components, omega cos lambda and omega sin lambda. First component is along y-axis, second component is along z-axis. Let the particle is moving with velocity v in xy plane. So velocity vector has two components, vxi cap, vyj cap. So the Coriolis force acting on the body is given by due to the motion of the body. Coriolis force is a fictitious force whose value is given by minus 2m omega cross v, and if we wish to find out its value, it will be calculated like this: I cap, j cap, k cap. Omega has two components, x component 0, y component, z component. It has Vx, Vy, 0. So minus 2m. If we do the cross product, zero minus Vy omega sin lambda I cap plus Vx omega sin lambda minus 0 j cap zero minus Vx omega cos lambda k cap. So what we are left with, f Coriolis, it will be minus 2m minus Vy omega sin lambda I cap plus Vx omega sin lambda j cap minus Vx omega cos lambda k cap. Minus and omega sign comes common, then it will become plus 2m omega Vy sin lambda I cap minus Vx sin lambda j cap plus Vx cos lambda k cap. So in a simplified way, Coriolis force can be written as 2m omega sin lambda common Vy I cap Vx j cap plus Vx cos lambda k cap. So this is the expression for the Coriolis force acting on a body on the surface of Earth. So now the acceleration due to Coriolis force is given by the acceleration due to Coriolis force is given by so acceleration is force upon mass. So as we are to find Coriolis acceleration, so it will be Coriolis force divided by mass. So m cancels, so it will be 2 omega sin lambda Vy I cap Vx j cap Vx cos lambda k cap. So this is the expression for Coriolis acceleration. So it will be having two components. One is horizontal component of acceleration, which is in xy plane. It is 2 omega sin lambda Vy I cap Vx j cap, and one is vertical component, which is 2 omega Vx cos lambda k cap. So this is our finding. So based on this, now we will try to answer few questions. So first part is fact of Coriolis force. We will be having two facts due to two components of acceleration. Fact of Coriolis force. So A part, due to horizontal component of acceleration. Due to horizontal component of acceleration. Number 1. We will divide this section into two parts. If the object is moving along positive x-axis, if the object is moving along positive x-axis, so we draw a coordinate system. Firstly, we draw a plane. This is a planar motion, say surface of Earth, and on this we draw a coordinate system. Let this is the x-axis, this is the y-axis lying in the surface of Earth. This is the origin, and this is the z-axis. Z-axis is the vertical axis, and our object is moving with velocity v along the positive x-axis. Now what will happen? If the object is moving along the positive x-axis, then our velocity, it will be consisting of only x component. Y component will be 0, and if y component is 0, then acceleration in the horizontal direction it will be equal to 2 omega sine lambda 0 I cap minus Vx j cap. So when we solve this, it will be minus 2 omega Vx sine lambda j cap. So this acceleration is along negative y-axis. So body will be moving towards, firstly starts moving towards the positive x-axis, then it will be shifting towards negative y-axis. All these calculations are in the northern hemisphere. Whenever we draw the diagram, we always take the point P in the northern hemisphere. You can also see the previous article here. P is in the northern hemisphere. All the articles that we are doing, we assume the particle to be lying in the northern hemisphere. So when the object is moving along the positive x-axis, due to Coriolis force, it has shifting in its direction of motion, tilting towards the negative y-axis. Number 2, if the object is moving along positive y-axis, if the object is moving along positive y-axis, then what will happen? So here velocity, it will be consisting of only y component. X component of the velocity vector will be 0. So we again draw the diagram. Suppose this is the surface of Earth. These are the various axes: x-axis, y-axis, z-axis. The object is supposed to be moving along positive y-axis. Now we will see the horizontal acceleration. It is equal to 2 omega sine lambda, 2 omega sine lambda Vy I cap Vx j cap. So Vy I cap minus Vx, x component is 0, it is j cap. So it is 2 omega sine lambda Vy I cap. So it is moving towards positive x-axis. Positive x-axis is this way, so it will be moving towards y-axis and shifting slightly towards positive x-axis. Shifting slightly towards positive x-axis. So what is the conclusion? Conclusion: due to the x component of Coriolis force, that if the object is moving in northern hemisphere, it is deflected towards its right. It is deflected towards its right. So you can see it is deflecting towards the right hand. And if it is moving in southern hemisphere, so it can be proved that it will be moving towards its left hand. So for that we will have to redrive the complete formulation again, but in the conclusion we can directly say that when it is moving in the southern hemisphere, it is moving towards the left hand of the body. Now second component is the vertical component. Second component of acceleration is vertical component, 2 omega Vx cos lambda k cap. 2 omega Vx cos lambda k cap. So it is along positive z-axis, which is opposite to acceleration due to gravity. Gravity is vertically downward, which is along negative z-axis, and the vertical component is along positive x-axis, so they are in the opposite direction. So due to the vertical component of x Coriolis force, it slows down a freely falling body. As both are in the opposite direction, so due to this the net acceleration due to gravity will decrease. So dear students, the Coriolis force which is there due to the angular velocity of the body that is due to the accelerated motion of the frame of reference. Whenever a body starts moving, it will be started feeling the effect of Coriolis force, resulting in two components of acceleration, horizontal component and vertical component. Whenever there is a horizontal motion, the effects are felt in the terms of horizontal acceleration. That is, a body is slightly tilting, moving, changing its direction towards its right hand when it is moving on the surface of Earth. Whereas due to the vertical motion, whenever a body is there in a vertical motion and due to the vertical component of acceleration, which is opposite to acceleration due to gravity, it starts slowing down. Net acceleration is reduced. So this is all for today. Keep in touch for next lectures. Thanks a lot.